So we've kind of gone through JavaScript, and then we've spoken a bit about Node and the mean stack. So microservices is an emerging architectural approach. They are typically a sharp unit of functionality. The term was first coined by a guy called Fred George. If you haven't seen Fred talk or any of his videos, go check him out on YouTube. Just search for Fred George. There's some excellent talks on microservices and also on programmer anarchy. Fred's a great guy. He's I think, I'm not sure what age he's getting on, but he still codes every day. So pretty good legend. He defines it as around 100 lines of code. I think that's maybe a little small. Might need to be a little bit bigger than that. All depends. But the key thing is that it does one thing and only one thing. A system that is built using a microservice architectural pattern is assembled from lots of microservices, lots of these units. That doesn't necessarily mean that the entire system is built out of microservices. What it means is that you might have a front-end piece which you're using a mean stack and traditional-ish, but an Angular Express type route into the system, and then the rest of your processing or internal work is done through a microservices approach. So it's the aggregation of all of those microservices. So why would you? What's the difference, and why would you bother doing that? I find that software development is really kind of difficult. I've been doing it for about 20 years, maybe even longer than that. It's too long, really. But for me, I still find it very difficult to develop software. I think anyone that's been in the business long, for any length of time, will have many stories about how they've been humbled and made to feel completely stupid by their own code. I know I certainly am on a daily basis. I was actually so worried that I actually went and got a brain scan done, and that's the result. So that's probably my problem. You guys are obviously a lot smarter than me, but I think that the route to kind of solving a lot of these software problems is simplicity, to strive for simplicity all the time. Back when I was younger, I wrote some systems in something called LabVIEW, which is based on a language called G. It's a graphical programming language, so you wire up boxes.
It's been taught here, which believe.
Is it really LabVIEW?
Yeah, in physics, yeah.
Yeah, I'd say it's. Oh, it's still in production, right?
Yeah, it is.
It's a great tool. It's a really good tool. LabVIEW allows you to create sub-diagrams and link them together like subroutines, which is the way you should do it. You don't always do it like that. And this is one of my favourite LabVIEW. Right? That's a program. That's a LabVIEw program, right? Now, this is a great picture because it illustrates spaghetti code. It really has spaghetti, right? To me. How anyone can make sense of that coming into it is beyond me. But you get the same thing in text-based programs, right? You get you can get all of that complexity and worse. It's just kind of surface like this. I think you were talking that Chris gave a talk. Right.
Yeah, Chris was showing us some walls of.
Yeah.
There were diagrams generated by these tools.
Yeah.
Of substantial enterprise systems.
Sure.
They were just terrifying, really.
Yeah, absolutely terrifying. So building large software systems is a very complex undertaking, right? So if you liken it to building a house, building a house is complex enough. If anyone's ever built their own house or even thought about building their own house, it's a complex process. Building a city, things get exponentially complex, and I think it's similar to that. Some of the forces we have to contend with in software are complexity, and entropy, coupling and repetition. Entropy is the killer. Entropy will always get you, right? Unless you actively fight against it. And anyone who's developed any software systems that have had any time in the field will know that there's people just put a quick hack in, just to get it working. Not sure what could go wrong. And then a few weeks later, someone else puts another hack in. And over time, the architecture gets bent and twisted. That's entropy at work. And it'll always kill you until you get to the point where no one can actually understand the code anymore, and you have to throw it away and start again. It's all about the management of technical debt. I've never ever written perfect code, and I don't know anyone who's ever written any perfect code ever. But if you know someone who has, please do introduce me, because I'd be delighted to meet them. And all software has some level of technical debt. It's about managing that technical debt, right? So I guess as engineers, or as architects, or whatever you want to call us, programmers, we're always searching for better ways to manage that technical debt. We're always trying to make things better, right? And we've gone through many iterations on that, and we're continuing to iterate. And you should view a microservice architecture as just another iteration on that process of trying to make things better. It's not the be-all and end-all solution to everything, but for my money, it's a very interesting way of managing that debt and improving things.
When does this become default and then bankruptcy? Is that
correct? Yeah, there you go. when no one person can understand the side effects of what they're doing in code. Right?
That's bankruptcy.
I think so, yeah. Because you're writing, I've got to change this function, but if I do this, it's not going to break over there.
Yeah.
So tests are a way of managing technical debt, right? Yeah. Because they'll tell you if something breaks, or they should. They might not tell you at unit level. If you've got an integration test, they might tell you. So decoupling and simplicity are the key ways of managing everything.
Is there an analogy to flip it over into credit? Have you ever been in a project that wasn't credit?
No.
Never.
I can't think of one.
It's always this.
Always. I can't think of a project that was in technical credit. I don't even know what technical credit would look like in a software project. What would it look like?
You sleep at night.
That's what alcohol's for, right? Sorry.
I suppose credit would be you are empowered to make changes that aren't needed.
Perhaps, yeah. Perhaps that might be one definition, yeah.
Or you feel empowered to do that.
You feel empowered, yeah, perhaps. Interesting. Sorry, I've just realised my next slide is a clone of one I had in the other one, so there you go.
We have Java, you know. I was going to say change the language again.
JavaScript, yeah, I did it in the last one. So I guess we've gone from kind of these types of patterns of what we've been through. We were through mainframe terminal clients, MTIA, SOA, enterprise service bus, type ways of doing things with Java application servers, all that kind of stuff. Microservices is the next evolution. What do I mean by that type of architecture? So what we're driving at here is, instead of having a large, complex OO piece of code, where you've got many classes, and within those that class infrastructure you've got patterns, you're using the kind of gang of four approach to building systems, and that can result in applications that are deployed into app servers that can be many hundreds of thousands of lines of code put together. We're talking about the decomposition into individual service elements. And each of those service elements is typically a separate process that does one thing. Now, our approach, or our view of this type of, and this is not set in stone, by the way, this is still an evolving concept, is that it should be centralised around some kind of messaging system, or message bus. Not everyone views it like that. Some people are doing microservices where they're doing point-to-point calls using HTTP. It depends on your system. We think this is the general approach, is to tie these things together with the messaging infrastructure. But the key thing is that each one of these is a separate component. So rather than it being a subset of classes which are hooked into a larger code base, within this type of model, it's a completely independent unit. That means that it can be, in production, can be independently deployed. So if I've got the same service living in this pool, this pool, and this pool, and I want to replace it for whatever reason, maybe it's not performing as it should, it's buggy or whatever, I can just replace that component without affecting the rest of the system. Whereas if I need to do a deployment on this system, I have to do a rigorous QA cycle, because although I've got testing in place, hopefully, and I've got integration tests in place, I don't know that there's not going to be any side effects without running through all of the manual tests and everything to ensure that my changes haven't affected it. And that leads to, that tends to lead to very long development cycles, because if you've got to go through all the effort of doing all of that testing, well, we might as well do this bit as well, and this bit as well, and then you've got to reschedule and all that stuff together. Under this type of system, what we're talking about is being able to put stuff out into production very quickly. So this microservices approach supports that kind of continuous delivery model, where we should be able to deploy into our production system on a daily or hourly basis, if we so wish, because we're only touching one component. So if it breaks, we can roll it back very quickly, or we can roll it forward very quickly without affecting the rest of the system. To my mind, it's a little like the analogy I like to keep in my head is the Unix command line. So when you look at the Unix command line, there's a lot of very, very sharp tools, and they do one thing well. So when you first come into kind of using when developing software, you might start using ODEs, and you find, geez, ODEs are really powerful, but it's like a big thing with loads of stuff in it, and it's not doing one thing, it's doing many, many, many things, and they're all kind of coupled together in a kind of weird kind of way, which is this. Then when you get a little bit more into it, you understand the power of just using plain text and how powerful that can be, and how just using the command line you can get stuff done a lot quicker. And you mentally come to this kind of model anyway, where you're using single things and you're chaining them together, you're piping stuff together, you're redirecting through files, all that kind of stuff. So I think, in my head, it kind of aligns with that view of the world a lot more, but maybe that's just me. So the characteristics, as I said, we've got some kind of messaging channel. It could be direct HTTP, queue, message bus of some kind. Lots of other services, each doing just one thing. We can have multiple instances of those services for scale across the bus. The way we approach it is that we pattern match. So when you want to execute a service, we place some JSON onto the bus. So for example, you might place a tweet command with some data onto the bus. That will be picked up by services. And the tweet, because of the pattern matching nature of the services, when the tweet service sees a tweet command, it takes it and executes it, and it will ignore anything else. Okay. Some simple rules for microservices. Each service needs to report its status. Each process needs to self-report its status. If there's an error, die and restart. We don't care too much. If you miss one message, you miss one message. And we continually test the business outputs of the system. So look at the outputs. Once I've done a deployment, do the outputs change in any way? Is it likely that deployment has caused a certain pathology in the system to occur? Services have short lifetimes. Should be able to update and remove a service without affecting the system. Should be able to replace a service in less than a week. One guy on the team should be able to replace a service in less than a week. If you're getting bigger than that, then you're not doing it right. Services should be language agnostic. So whilst we think that Node is a great way of writing microservices, and it's a great language, and it's a great way of being productive, you should be able, your systems should be language agnostic. So you should be able to mix in, if Scala or another language like that is a more appropriate tool for the specific job, then you should be able to use that tool for that service. So we're not prescriptively saying that it has to be, every service has to be Node. Use the appropriate tool for the job, and by having that decomposed type of architecture, it allows you to kind of develop your code in that way.
Can I just ask one question about the previous slide? You said,
sure, yeah.
What was it? Did I start on air?
What about something critical task? You just have to restart that task. You know, let's say.
Yeah, I liken it to the kind of embedded world, where excuse me, if you've got an embedded type system. Typically, what happens is if you get an error, you'll just go, oh, I don't like it, reboot, right, and just start again, because it can't really know anything about the state of the electronics or anything like that. So it's just restart. Now, once you restart, you should make every attempt to flag that you're restarting. There's been some pathology that's occurred. So typically, we might define like a system channel or a log channel where the service can just say, I'm dying, or I've handled this, or I've not handled this, or whatever it is. But generally, dying and restarting is a good way of handling errors, as long as you flag that that's occurred. Right? I've seen a lot of code get very, very complex because of complex exception handling. And at the end of the day, generally you can't really do much but start again. Do you know what I mean? Right? You could put a load of kind of clever error handling in place, but clever error handling usually goes wrong, which is why we kind of take that approach. Does that make sense?
Yeah, I can see.
So we did that one. Fred gives an analogy. He says that he thinks that microservices are like a living system. So he likens the services to cells in your body. Your cells, as you know, die and are replaced throughout your lifetime. So you're physically not made of the same material as you were made of when you were born or when you were growing. And neither should a software system. It should evolve with all of those components being replaceable over time. And as I said, it supports the kind of continuous deployment model, 5 to 10 minutes between deployments. That's pretty ambitious, actually. We haven't got to that point yet, but we're not as smart as he is.
So what do you mean by between deployments?
So Fred claims he can do 5 to 10 minutes to do a deployment, then another deployment in another 5 to 10 minutes time, and actually be that continuous about deployment.
New features or is it?
New services.
New services.
Yeah. We're not that good. So you're kind of growing the system in a more organic way. I've heard people refer to software engineering as being more akin to gardening than to engineering. That's kind of true when you think about it, because you'll try stuff and it might work and it might not work. And you might use it for time, then you might change it again, improve it. If you develop systems, you'll know that happens all the time. People coming saying, yeah, a bit of code I wrote last year, it's kind of needs improving because it's not performing well enough, or we need to do this, we need to have these features. So it kind of is a little bit like that. So allowing the system to grow and the architecture to evolve over time, and putting in place a structure that allows you to do that, I think makes sense. I think being able to rapidly deploy services is very important. And having the right tool for the job, I think, is important too. We shouldn't restrict people to using a specific language. And again, this is all good from a business perspective as well, because you're not stuck in one particular view of the world or one particular language. You've got to hire engineers that have specific skill sets. So, as I think I mentioned, Sunday Business Post. Check out Fred's presentations. Actually, we've got a few more systems now in production that are using this type of approach, and we're certainly learning as we go. We're learning a lot as we go, but our experiences to date are pretty positive with this approach. Okay, I think that's me on Microservices. I might just flip onto Capita and just get into some detail. Any questions on that, by the way?